His talk will explore how default configurations in architectures of our most commonly used software supply chain services can lead to a handful of unsavory outcomes, including secrets exfiltration, lateral movement, and privilege escalation within production cloud and SaaS environments. The title of Mike's talk is Attacking and Defending Software Supply Chains, How We Got Admin in Your Clouds. Please welcome Mike.
Thank you, Jessica. Turn off. How's everyone doing? How's my volume in the back? Good here in the front, good in the back? I got thumbs up, let's do it. Okay, hey everyone, my name's Mike. I guess I don't need to do an intro, we just got the intro. So we're talking today about attacking and defending software supply chains and how we got admin in your cloud environments. But first, a completely legitimate and safe QR code. This is linked to the talk. It's mostly for folks in the back. We only have such a big screen, so if you guys want to follow along on your phones, you can scan that link and that should go to a Google Drive. You know, buyer beware, but it's probably safe. Okay, to start, I need to not get stuck. That's the first step. Okay. To start, I want to talk about why we use software supply chains in the first place, and in particular, why we use CI/CD tools, right? Most of us are probably familiar with this. Really, what it comes down to is it's a forcing function of company success, right? A company of 10, 20, 50, even 100 employees, they can probably get away with having their entire engineering workforce have production credentials on all of their endpoints. They can probably get away with pushing to prod. But as a company grows and becomes more successful, 500, 1,000 employees, it kind of becomes impossible to do this, right? Everyone's just sort of stepping over one another. And so we need to productionize that process for everyone. That process comes with a couple of security benefits. For example, we can remove all of those credentials that might have originally been on all of our engineering endpoints, and we can instead have these individuals working on, with tools that they're kind of more familiar and comfortable with, like version control, GitHub, things like this. Typically when we talk about software supply chains and software supply chain security, I think we tend to think more upstream about like the open source providers and libraries that we end up pulling in. But the scope of this presentation is going to take a slightly different approach, and it's going to actually look at those tools that we use internally to our organizations and how we take code from source to production in those environments. And to level set, some of you might already be familiar with some of these tools, but if you're not, this might be a good refresher or a good sort of primer. So we're going to start with VCS and GitHub in particular. We won't spend too much time here. I think most people know what this is all about. The main thing that I want to talk about is really the big difference between your sort of free version of GitHub, your repos that you can turn public, make private, things like that. But with the enterprise version, you actually get something known as organizations, right, which is this logical boundary. In the same way that a repository is a logical boundary around your source for all of your services, organization is a logical boundary that exists for all of your employees and all of the repositories for your organization. And that allows you to do that sort of scaling that we talked about in the last slide by managing, access control, collaboration, things like that across all of those repositories. Now, if you're a company who is sort of in the beginnings of their engineering maturity, you're probably managing repositories all by the console, all manually. It's a good developer experience, allows your teams to move quickly. What that means, right, is that anyone's going to go and be able to make those repositories, and they'll have the permissions to manage things like collaborators, configure webhooks, branch protection and branching strategy and protection rules, things like not, allowing force pushes to main and things like this, but also setting up the CI, the configuration files for your CI, which leads us to our next slide. So continuous integration, we're going to talk about a couple tools in this space, but in particular, we're going to talk about GitHub Actions. GitHub Actions, the way they work is through workflows. GitHub Actions is probably the easiest tool to use with GitHub since it's just natively supported. The second that you turn on a repository or create a repository, you have GitHub Actions support. So they work through these workflows, and the way that it works is you define a set of jobs in your configuration files, and those jobs then run on a dedicated compute, a GitHub Actions worker. And the workflows themselves, those config files, are in a reserved file path. They're in this .github/workflows file path. So anything that you create there is going to be a workflow that runs for GitHub Actions. Now, for these workflows to be able to interact with the outside world, the way that they do that is by providing an identity of some kind, right? So this identity tends to be a GitHub token that gets assigned to the worker when that job kicks off, and it gives you access to GitHub APIs, things like secrets if the repository has any, and org-based secrets if those exist. Now, perhaps in those secrets, you're going to have other identities to your SaaS services, to your cloud environments, things like this. But perhaps a bit more elegantly is you might have OIDC federation. So you might actually not need those credentials so that you can actually allow your GitHub Actions workers to get direct access into your clouds through some short-lived OIDC-based operation. Now these workflows, the way that they work are through triggers, and the triggers are the event triggers that you're probably most familiar with. These are on push, a PR, on merge, things like this. And we can see an example of what this GitHub Actions config looks like here on the right. Okay, next CI tool is Buildkite, very similar to GitHub Actions in the way that it works. So it uses pipelines, just like workflows. And the pipelines are configured with this, typically there's a reserved file path that's associated with it. So usually it's like .buildkite in the same way that .github is for GitHub Actions. And it works with event-based triggers, very similar. The big difference here is that it's not natively integrated. You do need to configure this in some way, and the way that you do that is through a webhook. Again, very similar, it has agents for its identity, so you define an agent inside of the configuration file, and that agent is a token that gets provisioned on the runners, those are Buildkite's compute, and then that gets access through, IAM role, via AWS, service account if you're in GCP, Azure, or another cloud. And we can see an example of this on the right. So one of the things that we can see is the agent definition here, about 4 or 5 lines down. We can see the deploy artifact to prod. This is just a name that it's a bit pseudocode here. But it kind of shows that there's specific identities that we create to do specific things like run scripts and assume other IAM roles or service accounts. And this is kind of what it looks like in most environments. So we're going to go sort of one by one. Hopefully those of you in the back have scanned this code right here, if you can't see. But if not, here it is. I actually realized that I went so fast. You're like, hey, let me scan it. Yeah, there you go. Here, I'll give you a couple seconds. It's also on some of the desks in the back for those of you just starting to come in. Okay, we're moving on. I've only got 35 minutes, so I apologize if you didn't get a chance to scan that. Okay, so this is kind of what the workflow looks like. So kind of starting with step 1, someone submits some sort of PR or change to a repository. That repository has a handful of configuration files configured, whether it's using GitHub Actions, Buildkite, etc. Those have specific parameters based on those event triggers for when they trigger. So this is step 2 and step 3 here. When this runs, it's going to run some sort of CI-based check, linting, formatting, some sort of dry run, something along these lines, and it's going to run on a worker like we see on step 4. That has an identity that allows them to go and fetch other secret material, whether it's from GitHub Secrets or from, say, Secrets Manager of your cloud provider. And then there's some sort of review step that occurs here, right? So someone looks at the PR, looks at the changes, gives a +1, finally that code gets merged, and then after that merge, there's some sort of privileged write-based action, which we see in step 5. This is kind of a building an artifact, deploying to prod, something like this. It's worth noting at this point that GitHub Actions and Buildkite, I think they're pretty commonly viewed as CI tools, but there's this blurring of lines where they often are used for continuous deployment as well, right? That's kind of what step 5 is here, is this sort of privileged production write-based action. Which leads us into our next category of continuous deployment tools, and in this case, Terraform is probably one of the more popular ones in this space. And we can start seeing a pattern here. So with the enterprise and cloud-based versions of Terraform from HashiCorp, we have orgs. They act very similar to what we've seen before with orgs in GitHub. It's a logical boundary for all of the workspaces. And so these workspaces are basically defined one-to-one on a per repo basis. You might have subdirectories and repositories mapping to workspaces, but workspaces are responsible for managing all of the resources that you wanted to deploy into your clouds, right? So if you have an AWS provider for Terraform and you want to deploy AWS resources, you'd have a workspace dedicated for that. It dawns on me that this isn't true for the open source version. If folks use something like Atlantis, this concept doesn't exist. You might have to create something yourself. But this is how it works in the enterprise version. Next are state files, which are aptly named. They keep state, so they know the last known good configuration of the deployment that you've performed through a workspace, and that helps so when you make a PR or an incoming change, it can actually cross-reference that last known good configuration with the incoming changes and gives you a diff, and that's what the output of your dry runs or your plans are. The way that it does this is through providers. So providers do all the heavy lifting for Terraform. They're a binary that runs on the Terraform worker nodes, the compute for them, and it knows how to interact with all your downstream APIs. So you have AWS providers, and GCP providers, and Kubernetes providers. There's a bunch of them now. And so it knows what APIs to hit, it knows how the resources are configured, it knows what parameters it needs, so on and so forth. And it's a pretty similar reference architecture. We go through the same sort of flow here of code push, dry run, PR review, merging, and then deployment, steps 1 through 4. Okay, so this is kind of our refresher. So I've got a couple of assumptions here based off of the things that I've just talked about. The first question I love to poll the audience, so perhaps a show of hands. For those of you who have currently or have ever worked at a company, how many of you have seen that all of engineering is allowed to submit PRs to all of the repositories in your orgs? Just PRs. We got a bunch of hands. For those of you perhaps viewing at home in the future on the recording, I would say, honestly, it was maybe like 55, 60%. I'm wondering if it's more actually, but usually when I ask this question, because I've asked this question a couple times, it's around the 60 to 70%, but 50 to 55. Maybe our practitioners are a bit more mature at their companies, and they're like, no PRs. We'll see. So there are a couple of other assumptions though. The next is that branching strategy for most of our repositories is largely flat. So what that means is basically you have one protected branch, the main branch, and then all of the other branches that allow you to submit PRs. These are the things that you're going to review. Once they get merged, they move into this protected branch. So there's no advanced feature branches or multi-tiered structures. Chances are it's just sort of one protected branch and that's it. And then the third assumption is that it's predominantly up to service owners, engineers, to manage their own CI/CD workflows and pipelines. And what I mean by this is that there shouldn't be an expectation, there probably isn't an expectation on the infra teams to white glove the creation of all of these resources for all of these tools. There's probably some work that needs to be done by engineering teams to actually create set things up themselves. Probably with the help of infra teams. So, saying all of this, here's my problem statement. Engineers have access to create repositories, PRs, and CI/CD resources unilaterally within our organizations, and as such, they can create and trigger dry runs for new and existing workflows, pipelines, and Terraform plans for all environments from dev all the way to prod. So, why is this a problem? Let's find out. Now, to help illustrate some of my findings, I'm going to go through some of the creation steps that we just talked about in our reference architectures. So we're going to go through creating a repository and seeing how GitHub Actions can access some secrets, just by design. That, I'm hoping you guys can see this. It's a little small. So, okay, on the left side, we can see that this is the console for creating a new GitHub repository. And we're going and we're creating a repo called technologic-temp. Now on the right side, when we do that, we can go into the GitHub Actions secrets section, and by default, it gets access to repository secrets. There won't be any for a brand new repository, so you could create some of them. But the thing worth noting here is that any sort of org secrets in your GitHub org are just by default accessible in a brand new repository. So you just get that for free if you can create a repository in your organization. And you might see where I'm going with this, but for those of you who perhaps don't worry, my story gets better. Next up, we want to go and create a Buildkite pipeline and connect it to our GitHub repository. And so what we do here, and these are the steps. Step one is you can see the settings of the pipeline itself. So we can see that we've created a Buildkite pipeline called technologic-temp pipeline. It's connected to that technologic-temp repository. Step number 2 on the top right is just showing the event trigger settings. So that's basically saying on a pull request, trigger the build or the configuration that we've set up. Step 3 is actually fetching the configuration file from the repository. So this is done by some sort of, you can do this either through a personal access token or a deploy key in GitHub. Those aren't necessarily good ways to do it. You could also create a GitHub app and then just give it access, because it needs to be able to read from the repository to get that configuration file to know what jobs it needs to run. And then step number 4 is the webhook on GitHub's end that shows that it's actually sending that trigger based on the event to Buildkite, to that pipeline. And now you may be asking, yes, we see how this works, what's the problem? Maybe I'm dating myself here, but some Caddyshack fans maybe in the audience, we're waiting, what's the problem? So let's actually see what the problem is. So we're going to show how to create a GitHub Actions file, a workflow. And so on the left, we're creating this innocent-looking file. Spoiler alert, not so innocent. And it's trying to do two things. And both things are trying to fetch secrets from the org secrets that exist natively that have not actually been configured in any way that we just have access to. So this is showing this. In orange, we can see we're just trying to echo the secret. And Github does a pretty good job actually at stopping that. It's masked. However, if we're a little bit more clever and we perform a memory dump and then base64 encode it, well, we just see the blob right there. And that's what's happening in red. If you decode this, what you'd find is two things. One is the GitHub org secret that's just readily available. And two is the GitHub token that exists that is provisioned as the identity for the worker. And that has read or write access depending on how it's configured to your GitHub APIs, to your repository. It just depends on what the workflow is doing. And the same sort of thing is possible in Buildkite. So if you look at lines 1 and 2 here, we can see that the agent is being defined. Now this agent in the queue, known as prod, is it's just an arbitrary agent. It has nothing to do with the repository that we just configured. So it actually is associated with another repository, probably that has to deal with prod-based actions, and we can just arbitrarily define it in our own repository. So there's no access control that exists by default in Buildkite that says, hey, you can only access this repo or this agent, but not this agent. And remember, these are the identities that allow you to do things inside of other environments. And we can see that by running this sort of bash test command, which is just performing a get caller identity. So for those of you in AWS, the get caller identity just shows you the identity that you actually have become, and we can see that we've been able to assume multiple roles without having any sort of configuration of the identities before. All we did was create a pipeline to a brand new repository inside of our organization. Now you might say, Mike, engineers can't create repos and pipelines in my organization. We're okay, right? Nope, turns out that there's still some more problems. If that was the only thing that my talk was about, I'd probably be giving off some Tuxedo Mask vibes. I don't know if there's any Sailor Moon fans in here. I can't remember one time that he's been helpful in that show. That's been a couple of years, but anyway, I digress. Okay, so what else is problematic? The next couple of slides that I'm going to talk about is what I've been sort of labeling this pre-merge remote code execution. So if we go back to the very first slide that I talked about where we had some security benefits of productionizing our CI/CD tools, one of the benefits we got was removing all of these write-based credentials from our engineering workforce's laptops because we could allow our production services to do this for us. So what we look at here is GitHub documentation for GitHub Actions, and it says, warning, any user that has write access, which write access is the term for just being able to submit PRs to repositories, anyone with write access to your repo actually has read access to all of the secrets configured in your repository. Therefore, you should ensure that the credentials being used within these workflows have the least privileges required. So basically, to my surprise, and obviously to the shock of little Pikachu as well, basically what GitHub is saying is that this is outside of their threat model. We basically lose all of the protections that we assumed that we had by removing these credentials from our engineering endpoints and putting them into our CI/CD based tools instead. And why is this? Let's get into sort of the specifics. This is a meaty slide. So all of the things that we just showed about secrets injection for GitHub Actions and for Buildkite pipelines can exist for existing repositories. So you don't need to create a brand new one. And what that means is it opens up two new attack venues. One is if you have a repository already created in your organization and you can push to it, you can actually leverage the pre-existing configurations that exist, such as for OIDC-based federation from GitHub Actions to AWS or to GCP or to Azure, as well as Terraform repositories that exist or managing your infrastructure. And why does this work? The reason that this works is because the configuration of your GitHub Actions and your Buildkite pipelines and probably other CI and CD tools, they exist alongside the source code that you're managing in your repositories. They're in source. So when you submit a PR and you were to make malicious changes to those configuration files, they're just honored in the context of the PR. They'll just run. So there's no check. They'll just look at the PR and say, oh, you've changed those files? We're just going to run those files now with the integration that we already have set up. So let's talk a little bit about these two new use cases. The first one is GitHub-based OIDC federation. So the first step, number one here, is a configuration step. You can do it in whatever way you want. This is just showing it being configured through Terraform, so infrastructure as code. And the way that this works is that your GitHub token that we talked about in GitHub Actions, that token is a JWT, a JOT, and the way that we've configured this is that it allows it to do identity-based translation to actually go through AWS STS to get short-lived credentials. And those short-lived credentials are then provided back to GitHub Actions to then use. And the way that it works is through a trust policy, and this is true for GCP and Azure as well. I'm just using AWS as an example, but it's supported in all of the clouds here. The way that this works is the JWT that's being sent to AWS actually has inside of the subscriber claim all of the details of the repository, the org, all these types of things. So you define it there, and then in the trust policy you say, hey, allow this repo to go and get access to the credential for an IAM role, and effectively then it assumes it. So we can see that the permissions that are needed in the GitHub Actions is in step 3 as well. And here's an example of it. So we're creating a GitHub Actions workflow. We can see that it's trying to assume this GitHub Actions role, and then we're just performing a get caller identity, and we can prove here on the right that we actually have become this GitHub Actions user. So this is just a quick little example. Okay, next up, our second use case, our second new use case is Terraform. And I'm calling this the apply on plan bypass. So the way that this works, we're going to show a demo of this real quick on the next slide, but this is sort of the fake demo architecture. It's pretty similar to the reference architecture that we saw before. So we have this fake crypto exchange company, and the way that it works is, we'll submit a PR to the Terraform repository. They have 2 different work spaces. So there's a workspace for dev and a workspace for prod. We're using Terraform Cloud in this demo example. And they have compute for the Terraform workers. So a plan will kick off there, some sort of review is expected to happen, and then some sort of applying of AWS resources will occur. Now what the apply on plan bypass does is it actually sidesteps the whole review process. So things we'll actually be able to perform an apply during the plan phase without any code review and without any merging possible. So let's see that next. We're going to go and try and create an S3 bucket here. And so what we can see is the name of the bucket is going to be remove this test bucket, so we can see that right here. So if we go into our current AWS account and we refresh it, we got to make sure that that bucket doesn't exist. We can see that that bucket does not exist. So we go and create a PR, and this PR is going to kick off a webhook to perform a speculative plan. And so here's the plan right here. It begins to run, and we can see our malicious null resource that exists inside of it, right? And inside that null resource, it's actually performing a Terraform apply behind the scenes. The apply completes, and then we go back into our AWS account, and there's the S3 bucket. No code review, no merging required. And the reason for this, right, is that chances are Terraform needs to manage your cloud environments, right? So it probably has admin, and so what's happening is you can actually escape from the context of the plan down onto the underlying file system, and then use the same permissions that exist on that worker to instead perform an apply, and you get to do it kind of for free in the plan phase. So going back to our problem statement, anyone who can push or create PRs to a repository, chances are you need write-based access in some way. They can exfiltrate secrets from GitHub Actions, Buildkite pipelines, and from Terraform plans by bypassing access control to apply arbitrary code from unmerged and non-code reviewed PRs, and that in doing so perform secrets exfiltration. They can do privesc, and they can have lateral movement into other environments based off of the permissions of your CI-based infrastructure and your CD infrastructure. Okay, let's talk about remediations. Hopefully we do a little bit better than our Ice Age friend here. Okay. So there are a couple of suggestions that I have, and to start, it's really starting with a basic one, and we can see that there are the assumptions that we made a couple slides ago, they kind of correlate to some of the mitigations and suggestions that we have here. So this one is about config as code. Really, whether you use IACE, infrastructure as code itself, or you use a developer portal, something like Backstage if you have that in your environment, whatever it is, removing the manual creation step and having some sort of check is good, right? Like multi-prover is important. And doing it this way allows you to leverage modules, secure by default patterns. That allows us to keep a good developer experience. So that's the first one. Easy to say, maybe somewhat harder to implement, cross-functionally across an entire engineering org, depending on your size. The next thing is GitHub environments. Now, the goal of GitHub environments and the goal that we're trying to provide, the mitigation that we're trying to create, is we want an affinity between the GitHub secrets that exist inside of your org and inside of your repository with the GitHub actions that is running, and specifically against the branch that you're running it against. So you basically want, for all of your sort of pre-merge, so all of the PR-based branches, you want to be able to ensure that the permissions and the secrets that your GitHub Actions workflow is running with are less permissive, right? Are kind of read-only, because this is what we expect sort of in our CI-based environments. And then after a code review, after some sort of review, which is something that we sort of leverage very highly as a security control, once that code merges and has been reviewed, then in the protected branch in main, you can have the more privileged credentials, like write-based credentials, to go and push, which is your sort of continuous deployment-based setup. So what GitHub environments does is exactly that. You can create multiple environments and store secrets inside of those environments. So they're environment specific. You have to declare them and call them inside of your GitHub Actions configurations. But furthermore, you can create branch-based affinity and say, hey, only allow the main branch, your protected branch, to get access to these secrets. So anything that runs when something merges into main gets access to these secrets, and you can't get it beforehand. And we're looking for something similar in Buildkite as well. So for Buildkite, the goal is to create an affinity between pipelines and the agents that those pipelines can call, so that when you create a configuration file for your pipeline and you randomly define the agent like I did, you can't just choose a random agent that exists for another repository. You can actually use Buildkite clusters to prevent this. Now, Buildkite clusters, this functionality did not exist up until the beginning of this year. They GA'd clusters in February, and what it allows you to do, you can kind of see in this diagram here, is when you create a cluster, you can put pipelines and you can put agents in it. And if only the agents that are in that cluster can be accessed by the pipelines that are in that cluster. So that's what's creating that affinity. You can't extend to another cluster or outside of the cluster to try and leverage an agent that exists there. And we've talked about this already, but the last thing that we want to do is create some sort of branching strategy so that we create sort of this line in the sand that says, hey, prior to merging, prior to code review, we should have a bunch of branches that can do some fairly safer things. Maybe it only uses read-only based credentials. And then we have after code review and after merge, the more privileged identities that can actually perform maybe write-based things. That way you have environments for pre-merge, you have environments for post-merge, you've got pipelines for pre-merge, and you have pipelines for post-merge. And they're all associated with very specific branches that allow you to do very specific things. And with that, there's a sort of an updated reference architecture here. The big thing to note is kind of step 4. In our previous clustered Buildkite reference architecture, we were sort of cheating, right? We were able to cut the line and grab this privileged agent at step 4 when this sort of PR was supposed to run. And instead, we were doing write-based actions that should have occurred at 7, step 7 here. And we can't do that anymore with clusters because we don't want those privileged Buildkite pipelines to be able to get access to the privileged agents. Okay, same sort of thing in GitHub environments. We already saw this, but we can see an example of it right here. So how do we use GitHub environments? Take a look at our innocent-looking file attack that we did previously. We're going to try and perform it again a second time, but now we're doing it with GitHub environments in place. And the way that this works is you have to define the environment in your configuration now. So you can see that in red. The second job is trying to exfiltrate these secrets inside of the post-merge environment. And you can see in the top right, shout out to whoever did the UX and design for GitHub environments. I love those little like rockets. They look pretty sleek. You got kind of the green rocket that says, hey, that was successful. And then this red one that's like, didn't work. But the reason why it didn't work is we can see down here in the annotations that says, hey, this branch, pre-merge test, which is a PR-based branch that I created, is not allowed to get access to post-merge environments. You can only get access to it from the main branch. So we've actually prevented this secrets exfiltration from occurring because the job never ran that had the secrets exfiltration memory dump in it. The same sort of implementation with GitHub environments works with our federated identity use case too. And the way that this works is actually by defining the environment inside of the subscriber claim and inside of the trust policies for your clouds. So you actually add just another string to the end on the far right side that says, hey, this repo from my organization also has this environment, so only allow my pre-merge environments to get access to my read-only based IAM roles, for example, and then also only allow my post-merge environments to get access to my more privileged admin-based roles for app. For Terraform, we're going to talk about run tasks is basically the answer here. Run tasks used to be called Sentinel policies, for anyone who might be familiar with that. We'll talk about that in a couple slides. If you're using the open source version of Atlantis, though, the real answer to how to prevent these sort of unsafe built-in functions like no resource or run command, if you're using TerraGrunt or something like this, is to really, since you control the whole pipeline of how Atlantis runs, you want to serialize your webhooks so that you can inject some sort of code check, whether it's static code analysis or some sort of custom code, to check for these dangerous resources that are actually being implemented, so that when you see a null resource come in prior to a plan running, you can say, no, that looks unsafe, I'm not going to allow this to run. So then the admin can come in, take a look, review it, see if it actually is legitimate or if it's perhaps malicious, and then make a decision based on that. Okay, elephant in the room though. We've provided a handful of mitigations, but we didn't actually solve the problem, did we? Because the pre-merge RCE still works. Now, it may only be for read-only credentials based off our mitigations, but it still works. So what could remediation look like? Like if we could Thanos snap our solution into existence, or perhaps more realistically, if we were like in the shoes of the engineers building these tools, you know, what would we want to build and put in place? And I have some opinions on this. Mostly it belongs to GitHub. I think GitHub is really responsible for providing us with some of these these answers. And you know, how great would it be if we had granular access control on the subdirectory level? Right now, when we manage access for collaborators, it's just on the repository. You get read access, you get write access. But how cool would it be if you could say, hey, this specific team is allowed to submit PRs and push code that makes changes to this specific reserved file path. So only maybe repo admins can go and make changes to .github workflows and .buildkite pipelines. And even better, if someone tries to make a change who's not part of that group, prevent it prior to a push, prior to it ever hitting the remote origin. Because we don't actually have that event support. GitHub supports it. Their GitHub Advanced Security and their secrets solution actually uses pre-push to try and prevent secrets from landing in code, but they don't give that to us for free, or even if we pay for it, unless to do it ourselves. So how cool would we have pre-push as an event trigger? That would be awesome. And the last thing is about scoping GitHub secrets. So one of the issues that we have is if we wanted to move to GitHub environments, for example, from an existing repository that had a bunch of secrets, we'd effectively have to rotate all of the secrets into GitHub environments. Not a good user experience there. How many secrets you have to rotate all of them. Who knows where else they're being used? Things could break. Not great. How much easier would it be if you could just point, create some sort of access rule that says, this environment can use these secrets, just to find them in one place. Because this is possible for GitHub org secrets. You know, I talked about earlier where by default any new repository and any new GitHub action gets access to all the org secrets. You can actually custom tailor those to say, hey, only these repositories get access. How great would it be if we could do that for GitHub environments as well? Okay, and for Terraform, the enterprise version, let's talk a little bit about run tasks. I talked just for a brief moment about what they were. Sentinel policies is a custom language that you can define in sort of the intermediary steps between when jobs run during plan phases and during apply-based phases. To my knowledge, everything so there are some third-party marketplaces where you can actually download these run tasks from security companies and things like this. But to my knowledge, and based on everything I looked at, all of the solutions that are supported are during the pre-apply phase, which you'll note all of our attacks happened pre-plan, like during the plan phase. So we need some sort of mitigations to occur during that pre-plan phase. I have not seen anything that exists. Now, a lot of the documentation, a lot of the implementations are behind paywalls, so I wasn't able to test everything. So if someone knows actually about run tasks that run prior to plans that stop these types of things, I'd love to hear about it. I'd love to be able to talk about that. And the last thing I have, how are we doing on time? We're just about at it. Okay, gotta go quick. All right. So the last thing I want to talk about is brand new, and this one came out just a couple months ago, beginning of May really, and it's called GitHub Push Rule Set. So this is something that's in beta by GitHub right now. So if we go back a couple slides to right here where I talked about granular access control and event trigger support, how great would it be to have that? Well, we actually just got a feature that kind of does this in very specific way. So we can see in the bottom right the restricted file paths that it's defined. A push rule set actually allows us to set a specific file path and say, hey, these specific individuals are allowed to push to this file path if it makes changes. Anyone else will actually prevent it. So it's kind of exactly that we talked about. Now, because it's still in beta and it's brand new, it might be apt to break things. So if you don't want to turn it on in your prod environment right away, I don't blame you. But what you can do is you can set it to evaluate mode. And evaluate mode then lets you see what would break in insights, and then you can go back over the next 30, 60, 90 days and create those granular one-to-one rules that say, hey, this specific GitHub team and these set of collaborators can manage this specific workflow file because they own that one, and this other team can manage this specific pipeline in the repository, and that gets us that granular access control that we're looking for. So, last slide. Main takeaways. First and foremost, these findings, they're all still exploitable today, so make sure to implement any of these access controls and mitigations. And read the documentation for these tools, because I'm not the first person to have found any of these findings, but I don't hear anyone talking about how systemic it is, how it applies to basically all of our CI/CD tools. Now, I only looked at a couple, but I'm pretty confident that if we start looking at other tools, this pattern is going to emerge, because so many of these tools manage their configuration files inline inside of these repositories, right? So it's really up to us as practitioners to solve this problem and provide a paved path forward. Because the tooling vendors don't necessarily have all the answers yet, so it's up to us as an industry to provide these answers for them. And that's it. Thank you guys all for coming to my talk. I can take questions out back for anyone who's interested, kind of in the hallway or whatever.